Hey everyone, Mr. Fransky back here again. Today we're going to do some more examples with the Fundamental Theorem of Algebra, and this is, I think, the hardest thing that we have in Chapter 7. And I just want to do some additional examples that will hopefully kind of show all the different ways that we can do these kinds of problems. So first let's go over once again the different steps that we deal with in factoring these big polynomials. First thing you want to do is find as many zeros from the problem as possible. So they're going to give you some kind of information. They might give you a couple zeros. They might ask you to graph to find the zeros. They might give you a complex zero. And remember, if we have the complex zero, that the conjugate is always going to be a zero. So after we have that list of zeros, we're going to write out the polynomial with as many factors as possible. So if we know the zeros are 1, 2, and 3, then we know that the factors are x minus 1, x minus 2, x minus 3. So we're going to write out as many as we know, and then we're still going to have some kind of question as to what the last factor or two are. And then we're going to use division, either long division or synthetic division, to find the missing piece. And it's probably going to be a quadratic. Why is it going to be a quadratic? Because we have ways of finding the zeros of a quadratic, either with quadratic formula or by factoring using the Xbox method. And the last thing is we're going to do that. So we're going to use our quadratic formula or use the Xbox method to find those last zeros. This was in the last video as well. Just wanted to review it real quick. So let's try this problem here. So this is a cubic, we see, because we have the third degree right here. And we're given one real root. So let's read the problem together. And then if you want to pause the video and try it yourself, you can do that. And then we'll come back. So it says factor p of x, which equals x cubed minus 4x squared plus 6x minus 4, given p of 2 equals 0. So they're telling me here that 2 is a 0 of the polynomial. This is just another way of saying it, that when I plug in 2, I get 0. So if you want to pause the video now and see if you can give this a shot to try to factor out the entire polynomial, you can do that. And I'll see you in a few minutes. All right, welcome back. I'll try to pause a couple logical times to give you some chances to try different parts of the problem too, in case you weren't able to try it just now. So let's see here. We're told that 2 is a 0. So what I have been doing with these is I've been listing out my zeros. So we know 2 is a 0, but because of Fundamental Theorem of Algebra, we should have 3 zeros. So we're looking for 2 more zeros here. So I have 1 0, but it's a third degree polynomial. So Gauss's Fundamental Theorem of Algebra proved that there should be 3 zeros, so we're missing 2. And let's make a list of our factors too. So if 2 is a 0, then x minus 2 is going to be a factor. So now we've completed the first step of our procedure here. We have all the zeros that we know, and we have all the factors that we know. So now what we're going to do is we're going to write out, okay, that means p of x, which is, I'll just write it out again, x cubed minus 4x squared, plus 6x minus 4. We know that's equal to x minus 2 is our first factor, and then there's some big question mark here, multiplied by something else. And we can know that that should be a quadratic because we have a cubic here, and we're dividing by a linear is what we're going to do here, and that'll give us a quadratic. So what we're going to do now is, I kind of just gave it away, we're going to divide by x minus 2. Because if we divide by x minus 2, on the right side here, on the right side we'll just be left with our question mark, which is what we want to know. And on the left, we can do this using polynomial division or synthetic division. So if you want to pause the video again now and try to do it on your own with synthetic division, you can do that. All right, hopefully you had a chance to give that a shot, and let's go ahead and do it together now. So I'm going to put positive 2 into my box. A lot of people have been asking why we put positive 2 in there, and there are two good reasons for it. The first good reason is that the 0 is actually positive 2. The 0 is positive 2, so when I plug 2 into this polynomial, that's what gives me the remainder of 0, according to remainder theorem. Also, by putting in positive 2 here, you might remember that in long division, there's a lot of subtracting that happens. And it's really easy to mess up with the subtracting of negative numbers, especially when we have variables involved. So by using a positive 2, I can add in the columns instead of subtracting. And that makes our life just a little bit easier. So that's why we use a positive 2. So now what we do is we list out the coefficients of all of these, of all of our terms in the polynomial. So that's 1, x cubed, negative 4, x squared, positive 6, oh, don't need the positive probably, positive 6x, and then negative 4. I'll draw our line down here. That 1 comes straight down. If you're having trouble with synthetic division, go back and watch my synthetic division video. Multiply by 2 is positive 2. Negative 4 plus 2 is negative 2, times 2 is negative 4, plus 6 is 2, times 2 is 4, which gives us that remainder of 0. So our solution here is x squared minus 2x plus 2. X squared minus 2x plus 2. So what I've shown here is that our polynomial, x cubed minus 4x squared plus 6x, is equal to this quotient multiplied by what we just divided by, x minus 2. Because I found my question mark. My question mark was this x squared minus 2x plus 2. Now, if we want to completely factor this thing, we actually have to be able to factor this quadratic right here. I think I have another slide for this, yeah. So I'm actually going to write this out again. We have x squared minus 2x plus 2. So we have x squared minus 2x plus 2. And then it was multiplied by our divisor, x minus 2. This was our p of x. So we factored it a little bit. We're actually going to factor it just a little bit more. So this guy right here, it looks like we can't factor that. If we try to factor it, I don't think there's two numbers that multiply to 2 and add to negative 2. That's not going to work out. So we're going to have to use quadratic formula. So we have a here is 1, b is negative 2, and c is 2. So we're going to have negative b, which is positive 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c, which is 8, all over 2a, which is just 2. So we can simplify that a little bit. It's 2 plus or minus the square root. 4 minus 8 is negative 4. Well, looks like we're going to have some complex numbers, all over 2. So the square root of negative 4, that's 2i. So we have 2 plus and minus 2i over 2. Can split that up into 2 over 2 plus or minus 2i over 2, which is 1 plus or minus 2i. So those are our last zeros. So if we went back to our zeros list here, we can list those other two zeros because we just found them. So our other two zeros now are, should be 1 plus I. Twos cancel. So plus or minus I. So our two zeros are now 1 plus I and 1 minus I. So we got our last two zeros there. Now we're asked to factor it. So we want to actually factor this out. So if 1 plus I and 1 minus I are our zeros, then our factors will be x minus 1 plus I and x minus 1 minus I. Now why the parentheses? Because when I plug 1 plus I in here, I want everything to cancel out. I want 1 plus I and this 1 plus I to go away. So I have to have 1 minus 1 and I minus I, which is why we need parentheses there. So now we can write out all of these factors. I'm sorry, I keep switching screens here. So now we know that p of x, we just factored this guy. It's x minus 1 plus I, x minus 1 minus I, and then x minus 2. So we have completely factored our polynomial. If you were to multiply these three things together, easiest way to do that would be on a calculator, just to do an expand on that, and see if they equal p of x, and you'll find that they do. Or you could use a box if you want to do it by hand. Do a box on these two and then multiply by x minus 2, and it would work out as well. So that's our first problem. We were told to factor it, and we did. There are 3 linear factors. Third degree, 3 factors. Let's try another one. So this time we have a quintic polynomial, 5th degree here, and they want us to use a graph. So this time they want us to use a graph to completely factor this polynomial. And to graph this, we would need a calculator. And I actually have a graph here. I'm going to bring it up in just a second. But if you want to graph this on your calculator, see if you can find all of the real zeros. That's our goal here, is to find all of the real zeros. That's what graphing will do for us. So I'm just going to make a list here of the zeros. So if you have a chance to graph it, go ahead and pause the video and try graphing this and seeing if you can find what some of the zeros are. All right, let's take a look at my graph. Here we are. And it looks like we have 1, 2, 3 real zeros here. So you could use the menu analyze zeros to find what those are. But it looks like we can just find them by inspection here. So this first zero over here looks like it happens at -1, -2. So -2 is a 0. Looks like this next 0 happens at 1. And this last 0 here looks like it happens at 2. So my factors right now are going to be x plus 2, because remember we want that to cancel out, so that's why it's x plus 2. And then we have x minus 1, and we have x minus 2. So right now we have 3 factors. And remember, since we have a 5th degree polynomial, Fundamental Theorem of Algebra says we should have 5 factors. So we're missing 2 zeros here. And according to the graph, these are the only real zeros we have. So those should be complex. But right now, we know that p of x is equal to x plus 2, x minus 1, x minus 2, and then there's some question mark here, because if I just multiply these 3 together, we don't get the 5th degree. So there's some other, probably a quadratic once again here, that's going to give us the entire polynomial. So I'm going to rewrite this out on the next slide, because we're going to need a little bit more room to work. So x plus 2, minus 1, and minus 2. So we have x plus 2, x minus 1, and x minus 2 times some question mark is going to be equal to our p of x right here. Now, unfortunately, I don't think we're going to have quite enough time to finish this problem. So if you want to go back and watch the next part of this, I'm going to finish this problem. I'm going to do one more example of another polynomial division problem that will be useful for doing this idea of factoring big polynomials. So I will see you in the next video in just a minute.